The second section in Unit 2 is titled Solving Inequalities. So today we're going to start with just solving the one-step inequalities, which is very similar to solving one-step equations. So again, our standard is 7AF3, being able to solve inequalities. So there are several different pieces we're going to talk about. We're going to start with addition and subtraction though, because those are probably the two easiest. But make sure you write this down in your notes. When you add or subtract the same number from each side of an inequality, it will remain true. So for example here, this first if-then statement says that if A is less than B, and then you add C to both sides, the inequality remains true. Also, if you subtract C from both sides, the inequality will remain true. Similarly, if A is greater than B and you add C or subtract C from both sides, your inequality will remain true. So what you see in the examples here down at the bottom, and these numbers were all randomly selected, I started by saying that 5 is less than 9. That's true. I'm going to add 4 to both sides. 5 plus 4 is 9, 9 plus 4 is 13, and we get that 9 is less than 13. This is still true. So we've added 4 to both sides, the inequality remained true. On the right-hand side, we have 11 is greater than 6. I chose to subtract 3 from both sides, and you're left with the statement 8 is greater than 3, which is also still true. So just like with equations, when you add or subtract the same number to both sides, the inequality will remain true. We're going to look at some examples. When we solve inequalities, we show our work just like we do with equations. And we also want to make sure that we always write our answer with the variable on the left. And you'll see in a little bit why that's super important. So for number 1, we have x plus 5 is greater than 12. In order to get the variable by itself, we need to do the opposite of adding 5. We need to subtract 5. When you subtract 5 from the left side of an inequality, you also need to subtract 5 on the right side. So that gives us x is greater than 7. This is the solution to the inequality. So when you're asked to solve and graph, I will check for the solution, and then I will also check the graph. So on the graph, our number of focus is 7. We write a number smaller and a number bigger. They don't have to be consecutive. We're going to have an open circle at 7 because we are not including 7. This is just greater than. And we're going to shade to the right. These are where all of the numbers greater than 7 occur. You'll also notice that the inequality symbol, if you think of it like an arrowhead, is pointing to the right, so we shade to the right. And it's finished. Number 2, we have y minus 10 is less than 3. So again, we see subtraction. We want to do the opposite of what we see. So we are going to add 10 to both sides, trying to isolate the variable. That gives us y is less than 13. So again, this is your solution that I will check. We're going to plot 13 on the number line as well as 12 and 14. We're going to have another open circle at 13 because there's no line underneath. And now we're shading to the left. We're talking about all of the values that are less than 13. And again, remember that with an inequality can have and does have an infinite number of answers. We can't possibly list all of the numbers that are less than 13. And remember, it includes positives, negatives, fractions, decimals, irrational numbers, everything that's less than 13 would be included. Since we can't possibly list all of those, that's why an inequality and the graph are helpful. Now here we have an inequality where the variable's on the other side, which, remember, with equations it doesn't really matter. We're still going to get the correct answer if we do the right steps, but we'd want to make sure we put the variable on the left. So the first thing we're going to do is subtract 7 from both sides. 3 minus 7 is negative 4. You bring down the inequality and you bring down the variable. So we have negative 4 is greater than or equal to g. We can't graph it this way though because we would end up shading in the wrong direction. To say that negative 4 is greater than or equal to g, if we say negative 4 is greater than or equal to g, is the same thing as saying that g is less than or equal to negative 4. Okay, these two things say the same thing. We need to rewrite this inequality by flipping everything around. This will allow us to shade in the correct direction. Notice now the inequality symbol has switched to a less than, which means we'll shade to the left. So we're going to plot negative 4 on the number line. We're going to close in the dot because we are including negative 4. Remember, when you write numbers that are smaller than and greater than negative 4, we're in the negative, so make sure you write the correct numbers in each location. And again, we're shading to the left. So the reason why we always put our variable on the left is so that we shade in the correct direction. The next two properties, and we're going to do them one at a time. First, we're going to talk about multiplying and dividing by a positive number. So if you multiply by a positive number or you divide by a positive number, you still end up with a true inequality. So in the example down at the bottom, you'll see negative 6 is less than 10. If we multiply both sides by 2, we get negative 12 is less than 20. That's still true. Similarly, on the right, if we do 20 is greater than 16, divide both sides by 4. Again, I'm just randomly selecting a number to divide by. We end up with 5 is greater than 4, which is also still true. And here's the key word here, positive. Multiplying and dividing by a positive number does not change anything with the statement. So now we're going to look at another two examples. 5x is less than 45. So in order to get the variable by itself, we will divide by 5. That gives us x is less than 9. When we graph on the number line, we're going to do 8, 9, and 10. And you don't have to do consecutive numbers around 9. You could put 0 and 27 if you wanted to on the right and the left, or the left and the right. We want an open circle at 9, and we're going to shade to the left. Again, we're talking about all the values, all of the numbers that are less than 9 would fit in that equality and make it a true statement. So we shade to the left. Number 5, we have b over 8, where b divided by 8 is greater than or equal to negative 6. So dividing by 8, the opposite is multiplying by 8. So we're going to multiply both sides by 8. That gives us b is greater than or equal to negative 48. That equation, or that inequality, is now solved. So we're going to plot negative 48 on the number line. Also negative 49 and negative 47. Again, make sure you understand why it looks like it's going backwards, but that's because we're in the negatives. We have a closed circle at 48. We are including it, and we are shading to the right. We're talking about all the values that are greater than negative 48. And think about what some of those numbers could be. Decimals, fractions, all the positive numbers. So basically every positive real number would solve this inequality. Also anything negative that's negative 48 or greater. And now we have the part of the lesson that's a little bit different. And this is what happens when you multiply or divide an inequality by a negative number. When you multiply or divide by a negative number, you have to flip the inequality symbol in order for it to remain true. So the inequality symbol must be reversed for the inequality to remain true. And this is because of the rules with multiplication of of negative numbers. Remember that when you multiply something by a negative, it's going to change its sign. If it was negative, it becomes positive, and if it was positive, then it becomes negative. So we have to compensate for that by flipping the inequality symbol. You'll notice in our two little generalizations here, we have A is less than B, but if you multiply both sides by a negative number, you have to flip the inequality. Now it's a greater than. Similarly, if it's greater than, and you multiply or divide by a negative, now you're flipping so that it's less than. So I really want you to focus in on what happens when you multiply by a negative or you divide by a negative. Your sign has to flip. So if a negative 4 is less than 5, that's a true statement. But if I multiply both sides by negative 3, the signs are going to change. And because the signs change, I need to flip the equality to compensate for that. 12 is greater than negative 15. On the right-hand side, we have 18 is greater than negative 12. If I divide both sides by a negative 3, again, I'm changing the signs, so I have to flip the inequality. Negative 6 is less than 4. And I think we've got 3 examples to check this out. So number 6 is y divided by negative 4 is less than 3. So in order to undo division by negative 4, we're going to multiply by negative 4 on both sides. When you show this work and you immediately write that you're multiplying by a negative, the very first thing you should do is come down here and flip your symbol right away so that you don't forget. The negative 4's cancel, and you end up with y is greater than negative 12. So there's your solution with the inequality flipped correctly. Now we're going to plot negative 12 on the number line with an open circle, negative 11 to the right, negative 13 to the left, and we are going to shade to the right. We're talking about all of the numbers that are greater than negative 12. Number 7, we have negative 2f is greater than or equal to 12. So we're going to divide both sides by negative 2. Remember, that's the opposite of multiplication. But when we do that, we're dividing by a negative number. Doesn't matter what the 12 is, it matters what you're dividing by. We need to flip the symbol right away. So now we have f is less than or equal to negative 6. So we're going to plot negative 6, negative 5, negative 7 on the number line, closed circle, shaded to the left. So again, the reason we flip the inequality is because when you multiply or divide by a negative, you're going to change the signs on each side. So we have to compensate for that by flipping the symbol. For our last example, then this one's a little bit tricky, so make sure you're following along closely. But for the last example, we have the variable on the right-hand side. We know that in the end we want the variable on the left-hand side, and we also have a negative 3 in front of the variable. So in order to get rid of the negative 3, we're going to divide both sides by negative 3. Immediately that flips your inequality. Because you're dividing by a negative, we're going to flip the inequality. So we get negative 5 is greater than or equal to x. But earlier I mentioned that the variable has to be on the left. So now when we rewrite the inequality, we have to flip the symbol again. Negative 5 greater than or equal to x is the same thing as x is less than or equal to -5. So this one has two flips. And this happens anytime the variable's on the other side. We flipped once for dividing by a negative. And we flipped again to put variable on the left. So make sure that you understand the two different flips when solving the inequality. Now we can go ahead and graph -5 with a closed circle. We have -4 on the right-hand side, -6 on the left-hand side, and we are going to shade to the left. Anytime you forget to flip your inequality when multiplying or dividing, you're going to shade in the wrong direction, so you'll miss the solution and you'll miss the graph. In class, we will work on worksheet 5-2.